beneath a thin black line of sediment, buried at almost the exact same depth on 4 different continents. Researchers keep finding something that should not be there. Above the line, the bones of mammoths and giant ground sloths simply stop. Below it, an entire human culture was thriving across North America. For nearly 2 decades, scientists have argued about what that black line actually is. Then teams of them went back, pulled the layer apart grain by grain, and studied what was trapped inside. What they found sealed beneath it may finally explain how the last ice age truly ended. To understand why a single dark stripe of Earth has scientists so captivated, one must journey back to a very strange moment in the planet's history. Picture the world approximately 14,000 years ago. The great ice sheets that had buried much of North America and northern Europe were finally retreating. Glaciers the size of entire nations were melting back, and forests were creeping northward. Herds of enormous animals roamed open grasslands. Woolly mammoths, mastodons, giant ground sloths as large as small cars, dire wolves, American camels, and horses. For thousands of years the trend was clear. Earth was warming, the ice age was ending, and life was spreading into newly thawed lands. Then, roughly 12,800 years ago, all of that reversed. Almost overnight in geological terms, the planet snapped back into bitter cold. Temperatures in parts of the northern hemisphere dropped sharply, and the ice that had been retreating began advancing again. This cold snap lasted somewhere around 1,200 years, and scientists gave it a name borrowed from a small Arctic wildflower, whose pollen appears in the cold sediment from that time. The flower is called Dryas. The cold period became the Younger Dryas. What makes it so unsettling is that while the warming had been gradual and steady for millennia, the reversal was abrupt. Something interrupted the recovery of the entire planet, and it happened fast. The obvious question, one that has haunted geologists for generations, is simple. What flipped the switch? Now layer a second mystery on top of the first. Right around that same window of time, North America lost most of its largest animals. Mammoths, mastodons, giant sloths, saber-toothed cats. Dozens of huge species vanished from the fossil record in what feels, geologically, like the blink of an eye. And it was not only the animals. The people vanished, too. Not the human race itself, but a specific, widespread culture known as the Clovis people, named after a town in New Mexico where their tools were first identified. The Clovis culture is famous for one signature object, a beautifully made stone spear point with a distinctive groove or flute carved up the middle. For centuries, these were the dominant toolmakers across North America. Their points turn up from coast to coast. Then, right around the onset of the Younger Dryas, the classic Clovis toolkit disappears from the record. The culture either collapsed, scattered, or transformed into something else. Consider what that disappearance actually means on a human level. These were skilled, mobile hunters who had built their entire way of life around the great animals of the Ice Age. Their spear points were engineered for big game. So, when the mammoths and other giants collapsed, the Clovis people did not just lose a few species from a menu. They lost the very foundation their world was built upon. A toolkit that had worked unchanged in its essentials for generation after generation suddenly no longer fit the landscape. Whatever happened at this boundary did not only kill animals, it pulled the floor out from under the people who depended on them. Thus, 3 significant events occurred at roughly the same moment: a sudden global cold reversal, a wave of extinctions, and the disappearance of a continent-wide human culture. While coincidence is always possible, 3 major events stacking up in the same narrow window is the kind of phenomenon that makes scientists very uncomfortable, as it hints that one underlying cause might explain all 3, and that brings us back to the black line in the dirt. For decades, archaeologists excavating Ice Age sites across the American Southwest kept noticing the same odd feature. At locations like Murray Springs in Arizona, as they dug downward through the soil, they would encounter a dark, almost charcoal-colored band of sediment. A respected geoscientist named C. Vance Haynes spent years documenting this layer at site after site, giving it an unglamorous but perfect name: the black mat. The black mat is rich in organic material, which is partly why it is so dark, but the truly strange part is what surrounds it. Dig below the mat, and one finds mammoth bones, the bones of other extinct giants, and Clovis spear points. Dig into the black mat and above it, and those things are simply gone. The large animals do not reappear, and the Clovis tools do not reappear. It is as if the black mat is a line drawn across time itself, with a teeming Ice Age world on one side, and a strangely emptied landscape on the other. That alone would be a fascinating mystery. However, in 2007, a group of researchers published a paper that transformed the black mat from a curiosity into a battlefield. Their claim was bold. They argued that the Younger Dryas was triggered by a cosmic event, a comet or asteroid, or more likely a cluster of fragments that either struck the ice sheet or exploded in a series of air bursts over the northern hemisphere. The energy released, they proposed, would have ignited wildfires, destabilized the ice, thrown debris into the atmosphere, and helped tip the warming climate back into deep cold. In this telling, the black mat was partly the residue of that catastrophe. This idea has a name, the Younger Dryas impact hypothesis. From the moment it appeared, it became one of the most fiercely contested ideas in Earth science. Yet, a bold claim is only as good as its evidence, so what exactly were these researchers finding when they pulled the boundary layer apart? This is where the story moves from the shovel to the microscope, because the case for an impact does not rest on the dark color of the sediment. It rests on a strange collection of microscopic materials that teams kept extracting from the boundary. That thin slice of Earth precisely at the Younger Dryas onset. And these materials are the heart of the entire debate. The first are tiny spheres. When researchers processed the boundary sediment, they recovered minute magnetic and carbon-rich spherules, microscopic beads of material that form when something is heated to extreme temperatures and then cools so fast it freezes into a sphere. This kind of material typically results from impacts and very high-energy events. Finding a scattering of them might mean nothing, but finding a concentrated spike of them precisely at the boundary, with far fewer above and below, is harder to dismiss. Then there are the nanodiamonds. Researchers reported finding diamonds at the nanoscale within the boundary layer, including a rare form with an unusual hexagonal structure. This hexagonal variety is particularly interesting because on Earth it tends to be associated with the brutal shock pressures and temperatures generated by cosmic impacts. Diamonds, of course, normally require staggering pressure and heat to form. Finding them concentrated at one thin layer, dated to the same event, is a clue that is very difficult to explain with ordinary geological processes. And then there is the melt glass. At several sites, the teams found tiny fragments of glass that, by their chemistry and structure, appear to have formed at temperatures far higher than any normal wildfire or volcanic process at the surface could produce. We are talking about heat extreme enough to melt rock and sand into glass, the kind of heat one associates with a cosmic touch. Any one of these pieces of evidence on its own could be argued away. Spherules can form in other ways, and nanodiamonds have other possible origins. Skeptics were quick to point all of this out, but the proponents kept returning to the same point. It was not one strange material, but a whole suite of them, all spiking together in the same thin layer at sites scattered across the world. Then came the platinum. If the story needed a single piece of evidence that made even cautious scientists take notice, this might be it. Platinum is rare in Earth's crust, but it is relatively common in certain kinds of cosmic material, such as asteroids and comets. Therefore, if a large extraterrestrial object vaporized in the atmosphere or smashed into the ice, one would expect it to leave behind a faint dusting of platinum settling across the landscape. In a study examining the Greenland ice core known as GSP-2, researchers found exactly that. A sharp anomaly, a sudden spike in platinum, locked into the ice almost precisely at the onset of the Younger Dryas. Ice cores are like tree rings for the planet. Each layer is a year sealed and undisturbed. So a platinum spike at that depth is a timestamp. Something rich in platinum entered the atmosphere right when the cold reversal began, and the spike was just a Greenland curiosity. Later work reported finding the same platinum anomaly at the Younger Dryas boundary at numerous sites across North America. The same chemical fingerprint, at the same moment in time, showing up again and again across an entire continent. For the people who built the impact hypothesis, the platinum was the closest thing yet to a smoking gun. Now, let us leave North America for a moment, because one of the most striking pieces of the puzzle was found on the other side of the world. In Syria, there is an ancient site called Abu Huraira, one of the earliest known places where humans began the slow shift towards settled village life and farming. Researchers studying the soil at Abu Huraira reported finding melt glass there, too, fused material that, by their analysis, formed at staggering temperatures. Their interpretation was that a low-altitude airburst, a cosmic object exploding in the atmosphere above the region, blasted the ground with enough heat to melt the very dirt of an ancient settlement. If that holds up, it means the same event was not a single local strike. It was hemispheric, with fragments hitting or exploding over multiple regions at once, which is exactly what one would have expected if the culprit was not one solid rock, but a fragmented swarm. There is one more layer of evidence that ties directly into the climate question, and it is written in soot. When researchers examined sediment and ice from around the world at the Younger Dryas onset, several teams reported a sharp peak in the markers of burning, charcoal, soot, and the fine carbon residue left behind when vast amounts of vegetation go up in flames. Some of these studies described it as one of the most intense episodes of biomass burning in the entire record of that era, with fire signatures appearing on multiple continents at roughly the same time. Picture wildfires raging across a substantial fraction of the planet's land surface within a single window. That, the proponents argue, is the missing link between a cosmic event and a global freeze. Throw enough smoke, soot, and pulverized debris into the upper atmosphere, and the sun is dimmed. Less sunlight reaches the ground, the surface cools, and the result is what is sometimes called an impact winter. In that scenario, the comet did not have to cool the planet by brute force. It just had to set the world on fire and let the smoke do the rest. It is a chilling chain of cause and effect, and it explains how a brief, violent event could leave a scar in the climate that lasted more than 1,000 years. Now, let us get to the part of the story where the scientists fight back. Because for all of that, the Younger Dryas impact hypothesis is not the accepted, settled explanation in mainstream science. Not yet, and the resistance to it has been intense. The leading conventional explanation for the Younger Dryas does not involve a comet at all. It involves water. As the Great North American ice sheet melted, it created an enormous lake of glacial meltwater. The mainstream model proposes that at some point, a vast surge of that cold, fresh water suddenly drained into the North Atlantic. Fresh water is lighter than salt water, and dumping that much of it into the ocean could have disrupted the great circulation system that carries warm water north and keeps the northern hemisphere mild. Shut down that conveyor, the argument goes, and northern temperatures plunge. No comet required. This explanation has been the textbook answer for a long time, and a lot of serious scientists still favor it. So when the impact hypothesis arrived, claiming a cosmic V catastrophe instead, it ran straight into a wall of skepticism, and the extinctions have their own competing explanations, which muddies the water even further. One long-standing idea blames humans. The overkill hypothesis argues that human hunters, spreading across the Americas, simply hunted the slow-breeding giants to extinction. Another camp points the finger squarely at the climate, arguing that the wild temperature swings at the end of the Ice Age destroyed habitats and food supplies faster than the large animals could adapt. A few researchers have even floated disease as a factor. The honest reality is that the megafauna extinction is one of the great unsolved arguments in science, and plenty of experts believe it was a messy combination of pressures rather than a single knockout blow. The impact proponents do not necessarily deny that humans and climate played a role. Their claim is narrower and, in a way, more disturbing. They argue that a cosmic event was the trigger that pushed an already stressed system over the edge all at once, on a single bad day. That distinction matters because it is the difference between a slow decline and a sudden execution. The criticisms against the impact hypothesis were sharp and specific. Some researchers tried to replicate the spherule and nanodiamond findings and reported that they could not always do so, which in science is a serious problem. Others argued that the microspherules could form through ordinary processes like wildfires, or even modern contamination rather than a cosmic impact. The dating was challenged. Critics asked why, if a continent-shattering impact truly happened, there was no obvious giant crater to point to, and some accused the proponents of seeing an impact in evidence that could be explained more simply. The proponents had answers for each objection. The lack of a crater, they argued, fits an airburst or a strike onto a kilometer-thick ice sheet, which could have absorbed and hidden the scar before melting away entirely. The reproducibility problems, they said, often came down to differences in how teams collected and processed their samples. And they pointed again and again to the platinum, which is genuinely difficult to explain with wildfires or contamination. The argument went back and forth for years, paper after paper, in some of the most respected journals in the world. And that is exactly why scientists kept going back to the layer. Because the way to settle a fight like this is not with one dramatic discovery, but with patience. Over the years, multidisciplinary teams, sometimes comprising more than 24 researchers, pooling their expertise across geology, chemistry, and archaeology, kept resampling the same boundary at sites all over the planet. Each time, they were testing whether the strange signal held up under fresh eyes and tighter methods. And this is where the argument that is hardest to dismiss emerges. It is not any single material, it is the timing. When teams carefully dated the boundary layer at widely separated sites on different continents, the impact proponents argued that the layer consistently falls into the same narrow window of time, right around 12,800 years ago. A statistical reanalysis of the dates from multiple sites pointed toward the boundary being essentially synchronous across the northern hemisphere and beyond. Consider what that would mean. A wildfire is local, a flood is regional, but a thin layer carrying the same exotic materials deposited at the same moment across multiple continents at once is very hard to explain with anything that happens on the ground. That kind of synchronicity points upward toward the sky. So, what could deliver a blow across an entire hemisphere in a single moment? Increasingly, the proponents stopped picturing a single giant iron meteorite and started picturing something else. A large comet that had broken apart, leaving behind a stream of fragments and debris. Earth crossing through that stream would not take one hit. It would take a barrage. Multiple airbursts and impacts scattered across the globe, all within a very short span. That single picture ties the threads together. It explains the melt glass in Syria and the spherules in Arizona. It explains the absence of one enormous crater, and it explains why the boundary shows up everywhere at once. So has the debate actually ended? Here is the honest answer. In the strict sense, no single experiment forced every last scientist to agree. There are still respected researchers who favor the meltwater explanation and who remain unconvinced. Science does not usually end with a thunderclap. But here is what has changed and why this story feels so different now than it did when the idea first appeared. The evidence has not faded under scrutiny. It has accumulated. The platinum spike held up. The melt glass kept turning up. The synchronized dating across continents kept tightening. The collection of impact markers sealed in that thin black boundary has only grown harder to dismiss with each round of reanalysis. An idea that was once treated as fringe has been pushed slowly and stubbornly toward the center of the conversation. For a growing number of researchers, the question is no longer whether something cosmic happened at the dawn of the Younger Dryas. It is how big it was and how much of the catastrophe it caused. And that reframes everything we started with. The sudden cold, the vanished mammoths, the disappearance of the Clovis people. For a long time, those were three separate puzzles, with three separate, perhaps, answers. The boundary layer offers the unsettling possibility that they were never separate at all. That one event falling out of the sky 800 years ago reset the climate, emptied the landscape of its giants, and shattered the people who hunted them. If that is true, then the world you and I live in, the warm, stable, mammoth-free world of the last several thousand years, did not simply ease into being. It was born in fire and shock in a single terrible season, recorded forever in a stripe of dark sediment thinner than your hand. And there is one last reason this story should matter today. Just over a century ago, in 1908, a cosmic object exploded in the sky over a remote stretch of Siberia near the Tunguska River. There was no crater, but the air burst flattened approximately 2,070 square kilometers of forest, snapping millions of trees like matchsticks. That was one fragment over an empty wilderness, and we barely understood what hit us. The boundary layer beneath the black mat may be the fossilized memory of something far larger. A reminder that the sky is not as safe and settled as it looks, and that Earth has been ambushed before, so the next time you see a thin dark line in a cliff face or a riverbank, remember that the planet keeps a diary, and buried in one of its oldest entries, 12,800 years deep, is the record of the day the Ice Age did not just end, it was ended. The Carolina Bays, thousands of strange oval scars across the American landscape, are another phenomenon some researchers believe are the missing fingerprints of this very same event, hinting at further mysteries yet to be fully understood.